What's up guys, I'm Kaushik and it's almost August now, and you know what that means? It's placements time. Well, especially if you are a third year or a fourth year undergraduate in a college, your mind must be filled with millions of questions. Questions like, what do I even prepare for? Where do I even start? Where do I even prepare from? How to code? Where to code? In what language should I code? Should I just use C++ or should I use Java? Why Python? Why Python is literally the simplest language? Why nobody is using Python? Why people are suggesting against the Python? What is happening to this world? And there's so many other questions like, should I use lead code? Should I use HackerRank? Is my resume good enough for me? Am I confident enough to sit for a placement? Will I be able to speak fluently in an interview? I don't think I can able to do this. I'm done. I'm going to give up, guys. I'm going to do some MBA or something. I'm just done. I'm just going to give up, guys. And there are millions of other questions in your head right now. And trust me, I totally get it. And there's so much on your plate that I'm going to help you out a bit. So I'm going to give you a sheet or a cheat sheet or a list of topics or techniques in competitive coding that is going to change your life. Well, this list encompasses of different techniques, different topics as far as the competitive coding is considered. And this list is taken from my personal experiences, my friends' experiences, my seniors, their seniors, and their seniors. So it's a pretty huge data set, and I compressed everything into a one small list in which you just have to concentrate on these topics. And I'm gonna assure you that you can almost crack any coding round or coding interview that ever existed. Granted, you just have to practice hard enough and understand the topic, grasp the topic, and identify which question is what and comes under what particular topic. And if so, you're good to go. So I know you're super pumped for this, so without further ado, let's jump into it. First ever topic I'm gonna discuss is tree traversals. There are 4 tree traversals overall. It's pre-order, in-order, post-order, and vertical tree traversal. Well, you must be familiar with these 3. These are very famous. If you don't know vertical tree traversal, pause this video, open a new window, either open a solution for this or try it on your own or watch a tutorial video. I don't care, but learn it immediately because it's that important. And it's like if trees are ever considered as an interview topic, this is the first question they ever gonna ask. So just look onto that solution. Well, pre-order traversal is pretty simple. You just have to traverse to left node first, and then the current node, and then the right node. And post-order, right node, left node, current node. And in order, current node, left node, and right node. That's it. And the algorithms are as shown. And the questions they might ask as far as the traversals are considered is 1, vertical order traversal, and number 2 is, given a binary search tree, print the ascending order, something related to the ascending orders. You just have to use the in-order traversal and do whatever they asked in the question. So this is the approach. This is a topic which is very important, guys. The second topic I'm going to talk about is backtracking. And you must be familiar with what recursion is and how recursion work, and you must be knowing what is factorial or how to do power using recursions and so many other stuff. But backtracking is something you need to concentrate more on, guys. It is based on recursions, but knowing recursions is not enough to understand what backtracking is. And my favorite question of backtracking ever existed is solving Sudoku puzzle. If you are stuck and if you're not understanding how backtracking works, I think that would be a great example. Well, backtracking is nothing but there are millions of possibilities, right? So just traverse through the entire possibility, come back, traverse again, come back, traverse again, come back, traverse again. So you're gonna track, and if that's not the right answer, you just come back. You're solving Sudoku and it deviated a rule, so you just come back, change the value, and again go for it. So you're gonna backtrack it again. So my favorite question in this is Sudoku puzzle, and there are billions of possible questions as far as the backtracking is considered. But I suggest you guys to look into the solution, and I suggest you guys to first solve Sudoku puzzle, and try out and understand what backtracking is. It's very important, guys. It's asked in so many coding rounds especially. So the next topic is graph traversals. There are two important traversals. It's breadth first traversal and depth first traversal. And the main important thing you need to know is when to use what. Granted, you can just solve the same question using any of those two traversals with the same time complexity, but in an interview you must be more precise and more understandable to the question. So you have to understand when to use what. So in a nutshell, BFS is like, from a particular node, you just traverse all the node connecting to it and then go to some other node. Whereas in DFS, if there is a current node now, you'll just go to a node which is connected to it and then go to a node which is connected to it, and you go so on and so forth. So, and to understand these topics more precisely, my favorite coding question is rotting oranges. The link will be in the description, guys. So the question is like this, okay? So in the 2D grid, there are many oranges and few oranges are spoiled. So in one day, it's gonna spoil all the oranges which are adjacent to it. And how long will it take for all the oranges to be filled? All the oranges to be, spoiled. So it's a standard BFS question, guys. I mean, I'm not a spoiler alert. So yeah, solve that question or understand the question, see the solution. I don't care what you do, familiarize yourself with those kind of questions and you must be good to go. And my second favorite question for DFS is snakes and ladder game. So in an interview, I was asked to create a snakes and ladder game. It's basically, you have to create a graph, right? You just have to roll the dice and there are 6 possibilities. You can go 4 times, and yeah, that's a DF. That's something graph traversal related, and that's one of my favorite questions. So if you want to practice DFS, I suggest you to create a snakes and ladders game, and if you want to practice BFS, do the question rotting my oranges, and you must be good to go. And my next, and what might possibly be the most important topic and the most frequently asked topic, is binary search. You know, everyone knows how to use binary search. It's very simple. It's just a efficient technique to find out a particular element in a sorted array, right? Everyone knows that it happens in log n solution. But the two questions you have to concentrate more is, in a sorted array, if they are repeated elements, what is the first occurrence, and what index is the first occurrence of this particular target, or what is the last occurrence of this particular target using BFS. And the second question I want you to focus on is rotated array, which is basically, there is a sorted array and at one particular pivot point they just reverse the array. So it's like 1 2 3 4, so they just took 1 2 3 and put it at the end or something like that. And you have to use binary search to compute if there is the target element exists in this particular array or not. Try out the solution, guys, and if you don't understand, look at the solutions. These are pretty standard questions and you have to know what are they. So, and my next topic is regarding graphs again. It's minimum spanning tree. It's Prim's algorithm, Kruskal's algorithm, and Dijkstra's algorithm. These 3 are very important algorithms and you have to know what are those 3 algorithms. It's okay that, in coding interviews, it's pretty rare that they're gonna ask you to code Prims and Kruskal's and Dijkstra's, because it takes a tons of time to code, and they're just gonna ask you to explain mostly. But if they were to ask how to code, you must be in a position to code. So familiarize yourself with Prims and Kruskal's and Dijkstra's, guys. It's very important. And any graph question which are tricky will involve these 3 at least. So Prims and Kruskal's is minimum spanning tree. So from one particular point to another particular point, what is the minimum distance in which we can travel? And my Dijkstra's, it's again pretty simple. So from one particular point, what is the minimum weight to all the other nodes? So these 2 are very important, guys, and there's no particular favorite questions of mine in this. They're pretty standard, and the question will be hitting us right in our face. So it's very easy to identify where to use what. So, but again, as far as interviews is concerned, they might not ask you to code, but you must be prepared all the time, because in coding interviews they might not ask, but in coding rounds they might ask you to code. So look into it. And my next topic is not exactly a topic, it's a technique. It's called two-pointer technique. Well, it's a very famous technique, so it's basically nothing. So if there's a given an array, you just fix one pointer to initial value and you move forward and you change accordingly. My favorite question for two-pointer technique is a very basic one, but yet it will make you understand this topic or technique really great. So the question is, given a sorted array, you have to find out, you just have to swap out all the duplicate elements to the last and return the length of the number of elements which are there. By this, what I mean is, I'm going to explain with an example. So if there is an array called 1 1 1 2 2 3 3, you have to sort an array in such a way that it's 1 2 3 and 1 1 2 2, and that's it. 1 1 2 2 3, and you have to return the length 3 because there are only 3 different elements in the array, and the first 3 elements should be 1 2 3. It's pretty interesting, guys, and you will definitely, if you solve this question, you will definitely understand how pivotal and how easy and how magnificent these particular two-pointer technique is. So look into it. And the next topic is obviously linked lists. Well, linked list is not a very complicated topic, to be honest. It's tricky but not complicated. So there are various questions, but my favorite question is reversing the linked list array. Like they'll be giving a value like 3 or something, and for every 3 elements we have to reverse the linked list. So if the question is, if the linked list is 1 2 3 4 5 and they gave the value k as 2, first you have to reverse 2 1 and then 1 2 to 2 1 and 3 4 to 4 3 and 5 6 to 6 5 and return the linked list. It takes tons of time if you're a beginner in linked list, but it will make your basics so strong, guys, that you can solve literally any question in linked list. But yeah, another question you have to look into is reversing the linked list and how to find the middle value in the linked list. These 3 questions are pretty standard, and the first question takes time, but these 2 questions you have to be able to tell even in your sleep. So look into it. And next important topics are stacks and queues. Interviews like to kill our brains with stacks and queues, like how queue works and when to use queue. So you must be able to identify like where exactly should we use stack and where exactly should we use queue. So my favorite stack question is finding the minimum value in a stack all the time in linear time or in constant time, anything. So they'll be giving a bunch of values of stack with you, and same stack operations will be there, and as soon as any stack operation is done, you have to return a minimum value as well with the top value. So the link will be in the description, guys. That's a very interesting question, and if you are able to understand and get the reason why stack is taken into the consideration, you're good to go. And my favorite, another favorite stack question is obviously parenthesis matching. There's so many questions. So in the parenthesis matching, you just you check if if the open bracket is having closed bracket properly or not. If not, return, and you have to use stacks for that. So the links will be in the description, so look into it. Final topics which I wanted to put it at the last because the devil comes at last are greedy and dynamic programming, or DP. Well, it takes tons of practice to even identify if this question comes under DP or greedy, because there's a very silver lining between these two, very thin silver lining between these two, and it's very hard to identify sometimes. Well, it takes tons of practice, and if you are a beginner and if you're not understanding what DP is and how DP works, granted you have few easy questions like Fibonacci series using DP or power using DP, something like that, I guess. Or not even power. Fibonacci series is the best example to understand DP. But to gain more knowledge, I suggest you to do climbing stairs problem. Well, it's basically nothing. A person can climb either 1 step or 2 steps at a time, and given a number of steps, how much time or what are the minimum number of steps which are required to go onto the top. It's a pretty easy question, guys, but for beginners it takes a lot of time, and understand the question, write the normal backtracking solution, and try to put hash maps into it, do whatever you want, and then come up with a DP approach. And that's how I usually approach a DP question. I just do the brute force first, put on a hash map and store something, and after that change that into iterative solution. This should pretty much work almost all the time. And if you are feeling comfortable about dynamic programming, the question I suggest you to do is, what is the length of a maximum length of a substring, which is a palindrome in a given string? It's a standard DP question, and it literally eats your brain from inside. So obviously I'm kidding, by the way, but you'll see. So the links will be in the description, but do try them, and they're very important and they're very pivotal. So if you come across words like maximum, minimum, least, highest, smallest, largest, if something like this comes up, just look out for DP or greedy. Those will be your thing now. So before we wrap things up, there are a few honorable topics which are not related to competitive coding per se, but these are the topics which you need to know as far as the coding interviews are considered. So here we go. So you have to know string pattern matching algorithms, and you have to know how to find the most common subsequence or substring between two strings. These are standard questions, by the way. And you have to know the different sorting techniques, searching techniques, and what are heaps, how heaps work, how to implement heaps, which is priority queue. So implementation of priority queue, min heap, max heap, everything. Time complexities is another very important topic which you need to work on. In any interview you go, in any coding interview, they're gonna ask you to write the code. And when you write the code, they'll ask you to optimize it. And after optimizing it, they're gonna ask you to do a time complexity check. And they're gonna check how exactly are you gonna do it. So for time complexity, I suggest you guys to work on how master theorem works and how to write recursive equation. Very important topics these two are. So usually when they go for DP or greedy, the time complexity will be not more than n log n, because DP is used to reduce the time complexities. But if they ask you some graph related question, and if they ask you to find the time complexity, you must be in the position to write down the time complexity, the recursive equation, and compute accordingly. So look into these two guys, and I think that's it. I think you are equipped with all the important topics you need to crack a coding interview. So good luck. So there you go, guys, the cheat sheet or the list of topics which are mostly high frequent or very important, and do concentrate on these topics. Try to understand, figure out how these topics or techniques work, and if you are able to identify what question comes under what topic or what technique, you are 90% there. The 10% is just an implementation, which is very easy. It comes with the practice. So just don't give up, guys. Just practice on these questions. If you're not able to get it, look out for a solution. Don't waste much time. You don't have much time. It's placement season already, and all the very best. And I hope you get a good placement and succeed. So see you on the other side.